Okay, let's start our lecture. D class structure of D class हम कर रहे हैं। तो कुछ रिजल्ट्स हमने किए हैं। आज हम उन रिजल्ट्स को अप्लाई करेंगे एंड वी विल शो दैट H class जो है ना H class in a semigroup S, if it's non-empty, we will show that it is a group. It's a subgroup of S. Okay. So let's do one more lemma. Then we do the final theorem of this section. And the lemma is okay. Let's do first this exercise because we need this exercise in this lemma. So this we cannot do this. The exercise if we have H relation and AS is H related to A. If AS is H related to A in a semigroup S. In a semigroup S, then show that this mapping X to XS, which maps X, अब मैं यहाँ पर मैपिंग प्रिसाइजली नहीं लिखूंगा, X to XS, this which maps X onto XS. Okay, so this is a notation for that X to XS, which maps X onto XS is a bijection. This is a bijection. This mapping is bijection of HA onto itself. Of H class of A onto itself, HA to HA. Okay, solution इस exercise का by AS H related to A, it's a cursive H. AS H related to A, okay, in a semigroup S. Then show that the mapping X, which maps X onto XS, it's a mapping on S, right translation, is a bijection. If we restricted this map to HA, it's a bijection of HA onto itself. So by above lemma, by above lemma, if AS is R related to A, if AS is R related to A, जैसे वहाँ हमने किया था A is R related to C, then there is a bijection from HA onto AC, वो हमने किया है. If AS is R related to C, then there is a bijection. Then there is a bijection, and what's that bijection? That's the right translation. There is a bijection which maps X onto XS. Then there is a bijection which maps X onto XS. From HAS or HA onto HAS, HAS onto HA. ये हमने जो इससे पहला वाला लेमा है उसमें हमने किया है. वहाँ पर D रिलेटेड थे तो फिर वो C वहाँ पर आ गए, A is R related to C and C is L related to B, तो A और C के दरमियान HA और HC के दरमियान वो बाइजेक्शन आ गई, HA to HC if A and C are related. यहाँ पर AS और A are related है, so then this is a bijection from HAS on to HA. Now here AS is H related to A. Here AS is H related to A, so this implies AS is H is the intersection of L and R, related to A. That implies let's write here R here first. It's R related to A and AS is L related to A. So this means this implies the mapping which maps X onto XS, X onto XS. This mapping, it is a bijection. Okay, this mapping is a bijection from HA onto this is a bijection from HA onto HAS, but AS is H related to A, so that means H class of AS is same as H class of A, so HAS is same as HA because AS is H related to A. So we have bijection X which maps the bijection is that maps X to XS is a bijection from HA onto itself. Okay, हम इसमें सिर्फ ये part use करें, AS is R related to A. Okay, we are not using this one, and then finally we are using that this AS is H related to A. इसका use हम last में कर रहे हैं. HAS is equal to HA. That proves this exercise. So whenever AS is H related to A, then there is a bijection from HA onto HA itself, or HAS onto HAS itself. Lemma. If H is an H class, so this H is an H class in a semigroup S, in S semigroup S. In a semigroup S. This is not the lemma, sorry. Okay, this is actually Green's theorem. So the lemma is the following. If X and Y, they are H related, the elements are in a semigroup S. If X and Y be elements in S, if X, Y belongs to S, if this X, Y, the product, it belongs to HX, then rho Y restricted on Hx. This is a bijection of bijection. This is a bijection of Hx onto itself, of Hx onto itself, and if xy belongs to hy, if the product belongs to hy, if it is in hy, then rho x, then lambda x, okay, left translation, then lambda x restricted to hy is a bijection. Okay. This is a bijection. This is a bijection of hy onto itself. It's h class of y, okay? Hy on itself. Proof of this lemma. Rho y restricted to hx. Okay. So by above exercise we have seen that if as is h related to a, then the right translation x to xs, which is actually rho s, is a bijection of ha onto itself. So here we have xy, it is h related to x, okay. तो वहाँ पर क्या था एक्सरसाइज में, ए एस वॉज एच रिलेटेड टू ए, तो आपके पास ये थी मैपिंग, ये थी एक्स टू एक्स एस, ओके. तो यहाँ पर एस की जगह पर आपके पास वाई है, ओके, वाई. सो देयरफॉर the mapping which maps x onto, so here it's x onto xy, so it will confuse you, okay. So let's, अब अगर मैं s भी इंट्रोड्यूस करूँगा उससे भी आपको confusion होगा, so let's introduce z which maps z onto zy. This is a bijection. Is a bijection of hx, okay. एक्सरसाइज में ha हमने लिखा था, यहाँ पर hx onto itself. So what is this? This is right translation by y, that is rho y, okay, restricted to hx. This from hx to hx is a bijection. This is a bijection, okay. Is a bijection. So similarly you can say this lambda x similarly. आप इसको चेक कीजिए, okay. Let's verify this. Similarly, this lambda x, when we restricted this to hy, it's a bijection from hy to hy. This it's here small y is a bijection. This is a bijection. Okay. Now we have a theorem that's called Green's theorem. Okay, Green's theorem. Green's lemmas भी आपने देखे. Now Green's theorem. Actually ये आपकी main theorem जिसमें आपने Green's lemmas आप जब यूज करोगे या उनकी consequences जो आपने देखी अभी तक in previous two lemmas. The statement is if H is an H class, 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 in a semigroup S, in a semigroup S, in a semigroup S, then either H square intersection either H square intersection H is empty, or H square is equal to H, and in this case if H square is equal to H, then H is and H is a subgroup of S. In this case H is a subgroup of S. So this theorem guarantees the existence of subgroup under this condition. H square intersection S should be non-empty. Proof. So if the intersection is empty, then we have nothing to prove. If it's empty, subgroup, it's a subgroup. H semigroup है, but H is a subgroup. So in case H square intersection H is empty, then we have done. Okay, because either we have to prove this is empty or this is, or if it's not empty, then H square must be equal to H, and in that case H is a subgroup. Okay, then we have done. So assume their intersection is, so assume H square intersection H is non-empty. अब हमें प्रूव क्या करना है? H square must be equal to H. H square is equal to H. So clearly this H square, it's don't know whether it's subset or not, but let us take an element in H. So because the intersection, since the intersection is non-empty, so let's choose an element. Let X be in the intersection, or let's choose Z. Maybe we use X future. So let's choose Z. Z belongs to the intersection. Okay, and this implies Z belongs to H square and Z belongs to Z. So Z is an H square means that Z is a product of two elements. So this implies there exists A, B in H such that Z is equal to AB. Okay, and this AB is in H square, but Z is also in H. So this is in H. Okay, so we have two elements A and B such that this product is in H. This product is in H. Okay, now AB is in H, okay, and A is also in H. So therefore, let me write it precisely. Therefore, this AB is in H. Therefore, AB भी H में है और A भी H में है. Therefore, AB is H related to, not cannot say it's H related. Yes, they are H related because they are in same class, and AB is also H related to B. ये आपको समझ आ रहा है ये पॉइंट जो मैंने यहाँ पर लिख दिया है? Because A is in H, AB is in H, so H is H class, so it means that AB and A, they are H related. So, and AB and B, they are also in same H class, so it means that they are also H related. They are also H related. Now, as you have seen that if AS is H related to S, or you can say if we have two elements, say that that means, that implies, you can write this as AB belongs to H class of A, okay? AB belongs to H class of A, and here AB belongs to H class of B, B का H class. अब मैं इस H class का जो representative है ना, obviously this AB H class of A, this is equal to H, और ये भी H के ही बराबर है. अब मैंने यहाँ पर मैंने इसका representative B चूज किया क्योंकि वो भी H का एलिमेंट है, और इस केस में मैंने इसका representative A चूज किया है इस H क्लास का. So AB is in H, AB is in HB. Now we can apply the previous lemma. We can apply this lemma. So by above lemma, this row B, it's a bijection of HA onto itself, and here this AB, it belongs to HB. So in that case, lambda A. So lambda A, that is a translation to lambda A. Here it's HA, okay. Here it's HB, which is a right translation, and here we have HA, okay. HB, sorry, lambda B or lambda A, row B, sorry. So here we have row B because B is on right side and row B is a right translation, and here we have lambda B, I think it's lambda B because A is in a lambda A, yes, exactly, lambda, because A is on left side, so left translation. So therefore by above lemma, row B from where to where, from HA to HA, and lambda A, it's again from HA to, okay, right here it is HB to HB because they are all actually equal, or bijections, that is row B from H to H, and lambda A from H to H, because they are all equal to H. H is given H class, or bijections. They are all bijections. They are all bijections. Okay. So these two mappings are bijections. So that means this gives, what's the image of H under row B? It's HB, okay. And what's the image of lambda A, image of H under lambda A, it's AH. So that means HB and HB and AH. HB belongs, okay, let me write it and read. This is HB belongs to H for all H in H, and AH belongs to H for all H in H. So in other words, we have solutions for these equations actually. But this again gives now this HB is in H, AH is in H. Now again we apply the same lemma here. So here lambda H and H, for each H they are related, lambda H and H. This implies, what does it mean? This implies that this is this you can thought of as this one, this HB, you can think this as the left translation, okay, for each H. So this is a left translation, B is existing limit, okay, lambda, this is in H and AH is in H for every H. So this thing HB, so that implies AB, A हमने लिखा था, तो AB हमने A के बराबर लिखा था, वहाँ पर आपके पास रो B ट्रांसलेशन आई थी, AB is H related to A, okay, तो यहाँ पर है HB is H related to B, okay, AS is H related to A, so HA, okay. So what will we write here? Can we write here this HB? आप इसको थोड़ा वेट कीजिए, HB related to H for all H in H. Will you result it's AS, H related to A, so then there is a bijection which is rho S from HA to H, okay. इसी तरह से अगर आपके पास होगा TA is H related to A TA, then lambda T is a bijection from HA to HA, HA to HA, okay. यहाँ पर आपके पास HB है, it's T is on left side, okay. Here you have, if I will write here B, HB is, अगर मैं यहाँ पर B लिख दूँगा तो HB, okay. Let's write here B. So this way to fix actually. So this thing, it's B, HB. It's B, okay, because both are same H class actually, H, they are H related. So let's write here B. HB is H related to B, and here AH is H related to A. AH is H related to A. H is H related to A for all H in H. For all H in H. So now this actually now we have a mapping here which maps B onto HB, which maps B onto HB. So So that means your it's here actually left translation of lambda t, okay, lambda t, not lambda t, lambda h, sorry, so translation h is here, lambda h, okay, lambda h from hb to hp, that's equal to h, actually h to h, and here we have row h is on right side, from h to h, from h to h, actually h equal to h, are bijections, or they are bijections. ये ठीक है, यहाँ पर आपने वही बाय अबो लेमा यहाँ लिख सकते हो आप, यहाँ पर बाय अबो लेमा, बाय अबो लेमा. Okay, yeah, so this is by Abu Lemma. But what is the definition of lambda h? So that's important here. So this lambda h, this is bijection from h to h, okay, and this one row h, it is also bijection from h to h for all h, okay. These are bijections for all h in h. But row h maps the elements x in to hx, okay. So but it's a bijection, so that means this gives first one, it gives hh, so small h here, okay, it's on h is equal to this side on left side, h is equal to hh, and h is equal to hh for all h and h. You can easily vary because of these mappings, they are bijections for all h and h. So if you choose any element in h, that is here, but since this is a bijection, so you can find its pre-image, okay. अगर आप यहाँ कोई भी h choose करोगे ना, देखिए you choose any h here, not h, you choose x here, so that x must be image of lambda, image of certain element of here under this lambda h, so there should exist y. आप इसका यूज कीजिए यहाँ पर. So but from this h equal to hh and h equal to hh, it implies that h is a group. This implies that h is a group, because from this we have a equal to h, b has a solution in h, and here a equal to bh has a solution in h for all h and h. So this is a group, and hence a subgroup of, and hence a subgroup, hence a subgroup, hence a subgroup of S. अब देखिए आप h कैसे h के बराबर, मैं बस एक पार्ट आपको दिखा दूंगा. दिस h इज इक्वल टू h, ये हम चेक करेंगे, इसको हम वेरीफाई करेंगे. अदर पार्ट यू कैन डू. दिस लैम्डा h, इट इज अ बाइजेक्शन फ्रॉम h to h. आपको प्रूव करना h के बराबर. लेट्स चूज